But look, I might kickstart. I'm sure others will join as we're starting, but I'm very pleased to be running yet again another decarbonisation webinar. And this week we're very excited to be joined by Laurent Trost from Yara Pilbara, who's talking an overview of fertiliser for the future and aspirations around decarbonisation at Yara Pilbara, what they're actually doing and moving forward. And as director of the Institute for Energy Transition, we've been fortunate actually to do a little bit of a case study, which I'm sure Laurent might talk to, but it was really insightful for us to do that. But before we kickstart, I did just want to take a moment to respectfully acknowledge the Whadjuk elders, past and present, as the traditional owners of the Noongar Budja, on which Curtin Institute and Curtin University is located. Obviously, you've heard me talk before, the role of traditional owners in the energy transition is very exciting, or it should be, and we're all working hard to make sure that we can incorporate their knowledge and insight into the transition in perhaps ways that it wasn't done before. So there's a lot of lessons to be learned. And so just briefly on Laurent, he is the Chief Operating Officer of Yara Pilbara, and it's one of the world's largest ammonia plants situated in the northwest of Western Australia. Laurent is a chemical engineer whose career has taken him to operational management roles in Belgium, South Africa, Brazil, Russia, and France. So we are very lucky to have him based in Australia sharing his knowledge. So as we've done with all previous webinars, Laurent's going to share his insights, and then we'll open up to Q&A, and so that will be down the bottom there, people can type in. So Laurent, welcome, and over to you. Thank you.
Good afternoon, Peter. Good afternoon, everyone, and thank you for having me this afternoon. So I will just share my screen. I will introduce a bit who is Yara and then who is Yara Pilbara. Okay, now we are. It should be.
Perfect. Okay. We can see that. Thank you. I'll go on mute.
Perfect. So first, Yara, who we are. We are first, we are a Norwegian company, a Norwegian state-owned company at 35%, and the Norwegian sovereign fund owns Yara at about 5%, and the rest are individual or shareholders. So we have a mission. That mission is responsibly feed the world and protect the planet. And our mission is a collaborative society, a world without hunger and a planet respected. So we are facing global challenges, and we are Yara as a major fertilizer company. We have to face those big challenges, and the biggest one today is really feeding an additional 1.7 billion people by 2050. That's according to the World Population's prospects, and so it's reaching close to 10 billion people in that very quickly, and we have to feed them and to feed them with quality. And at the same time, we need to, in order to achieve the UN, the Paris Agreement targets, the 1.5 degree targets, we need a 45% reduction in greenhouse gas emissions that is needed by 2030 and to reach net zero by 2050. And as you might know, fertilizer industry, and not only the industry, the use of the fertilizer is a great contributor, unfortunately, of GHG emissions. So our role in that journey is quite important. And then at the same time, it's also doing much with less, because also we need to protect the planet, and ideally also we need to restore 1.2 billion hectares of farmlands that needs to be restored to nature by 2050. So the challenge is massive, is huge, and we have only a few years to achieve and to change the way the world is developing. Yara, we are global. We are a global company, and we have a global presence. So you see here in light green, all the country we are in, we operate, or we have offices and sales. And so we are 15,700 employees worldwide. We have about the last year was close to $16 billion revenue. We have 25 production plants mostly is located in Europe because our base history is Europe, but we have developed in Latin America, in Canada, in the US, and so in the Southeast Asian and Pacific Oceania area, we have only two plants, one in India and the one we have in the Pilbara. We are selling in 140 different countries, and we have more than 10,800 retail outlets globally worldwide. So this represents about 30 million tons of fertilizer sold per year, 30 million tons. That helps to feed about 240 million people worldwide. So we are representing more or less 6 to 7% of all the fertilizer distributed worldwide. So it's our global and major presence, and also our 120 years of experience help us also to shape the industry in general. Our operations, where we are located in the Pilbara. So here on the right side, you see the picture of the ammonia plant. So the ammonia plant and the nitrate plant, that represents a multi-billion-dollar processing precinct. And the location is quite important. We are located in recently nominated World Heritage listed, that's called the Murujuga, and that's a very important place for the Aboriginal culture. So we are part of, and we are working very closely and collaboratively with Murujuga Aboriginal Corporation. This place is extremely sacred in the Aboriginal culture. You see in the hills just behind, on the picture in the background, there are hundreds or close to millions of petroglyphs that for the most ancient are 60 to 65,000 years old. And of course, that's a unique place in Australia that we have to preserve and to guarantee that we keep this place as long as possible for the continuation of the Aboriginal culture. Our plant, the ammonia plant, is that's called Yara Pilbara Fertiliser. We can produce up to 850,000 tons a year, and that's the biggest ammonia production plant in Australia. At the time of construction, was the biggest ammonia plant in the world. That represents about 4 to 5% of the world's tradable ammonia. So our presence and importance is quite high for Yara, and especially for the Southeast Asian trading market of ammonia. But we are also a critical domestic supplier to different manufacturers, one in WA and two other ones in Queensland and New South Wales. And our export markets that represent most of the half of our production, we have key clients in Korea, Taiwan, Thailand, and Japan. And then we have an adjacent plant that's called the Yara Pilbara Nitrates, and this plant is a joint venture 50-50 with Orica, and we produce there 330,000 tons of technical ammonium nitrate. So our raw material is purely just ammonia, and the utilities are distributed by Yara Pilbara Fertiliser to buy Yara Pilbara Nitrates. And with the ammonia we produce, then we convert it into ammonium nitrate, and this represents more or less 43% of the total technical ammonium nitrate used in the Pilbara for the mining industry. So that's clearly a critical ingredient for unlocking the wells from the iron ore industry. We are based in Karratha, so we have an office in Perth where we are about 40 people, but we have 200 permanent employees living in Karratha with their families. We are a bit unique in the remote locations because we are not a FIFO fly-in fly-out mode. We are fully residential with our employees. Our employees, we have 166 company-owned and leased properties in the city of Karratha. And of course, we have a very culturally diverse workforce, which is one of our strengths. And as already mentioned, we have a very valued relationship with our traditional owners, and I come back with our decarbonisation journey. This is also key to involve them at the beginning of the definition of what we intend to do, and that's an important step step to get the acceptance of our operations in this region. So just to give some big numbers, so procurement, we have had about $345 million of procurement in 2024-5, then is mostly almost exclusively sourced from Australian vendors. And of course, as we are fully residential, we have very strong links to the different schools and the universities and TAFE, because also we want to develop and grow local workforce that are capable to work and continue to develop in the Pilbara. When it comes to our decarbonization journey, this decarbonization journey is not an easy one for an ammonia plant. So just to give you some more order of magnitude of what we propose, the 800,000 tons of ammonia we produce are unfortunately also generating 1.6 million ton equivalent of CO2 emitted to the atmosphere per year. This 1.6 million ton represents more or less 2% of Western Australia's total emission. So our plant is quite impacting when it comes to CO2 emissions. So we have started two ways of potential decarbonization of an operation like ours. First is the introduction of renewable hydrogen into our existing process. And with studies with KBR, our licensor, we have defined that we could inject up to 15-16% of renewable hydrogen into our existing process without a major modification of our ammonia plant. So then in 2020, we say, let's try to develop these routes, but starting with a pilot demonstration we can inject some hydrogen into our existing process, and also how to control and stabilize an electrical grid fed with renewable electricity. And that's called the URI project. That's the phase one. It's our URI project. I mentioned pilot, but it's an 18 megawatt solar farm. You see part of the panels on this picture. On the left of this picture, you have the remaining panels. That's about 20,000 solar panels that have been installed. We have the biggest electrolyzer units installed under installation in Australia. That's a 10 megawatt electrolyzer that's under mechanical completion at this moment. And it's also to guarantee a longer operation during the day. We have an 8 megawatt battery energy storage system. So this will allow us to produce about 0.9% of our total hydrogen need, and we hope to commission this plant in October, November this year, and we will be the first plant in Australia producing renewable hydrogen that will feed an existing ammonia process. So crossing the fingers for the end of the year that everything will run smoothly and we will be capable to produce the first green hydrogen in the Pilbara. And then the idea also is to produce and sell clean ammonia. Unfortunately, the volumes will be very low. We'll be representing about 1.9 kiloton compared to the 800,000 tons of total production. But this potential is interesting for Japan mostly, and Korea, who is already using clean ammonia to feed their power plants and to replace coal in their countries. And at the same time, this is something new and will be continued to develop renewable electricity, battery systems, electrolyzer. This is a new industry developing in Australia. So we are also offering training and development opportunities to government and industry, including the competitors. And we have even signed lately an MOU with Western Australian government, with Minister Sanderson, to continue the development of this collaboration, how to develop and train new employees for this type of future industry. Then comes the second phase of our decarbonization journey. So I mentioned 15% is the maximum that we could decarbonize through renewable hydrogen, but we have the biggest source of emission of CO2 from our plant is directly from the process. It's a byproduct from the conversion of the methane molecule, CH4, when we break the molecule into hydrogen, and we have a byproduct that is CO2. So the CO2, then we separate the CO2 and we emit it directly to the atmosphere. This represents about 75% of our total CO2 emissions equivalent, or 1.2 million tons. So it's an easy to capture CO2 stream that's directly from one vent into our plants, and then that's with the advantage of being in the Pilbara. We have also potentially two depleted gas fields. One is Reindeer, the other is Angel, where we could then capture, compress, we could then sequester the CO2 into depleted gas fields. So that's the CCS, the carbon capture sequestration project that we are developing. And that will be the swift solution to cut our emissions by almost 3/4. And as already mentioned, that will be close to 2% of Western Australia's carbon emissions. That's equivalent of removing 300,000 cars off the roads of Western Australia. So quickly, the process. So then we have our we are fed with natural gas, and so we are completely working on an island mode in the Pilbara. We have only two raw materials. One is natural gas, and the other is seawater. And with seawater and natural gas, we produce then ammonia and technical ammonium nitrate. So the YPF, Yara Pilbara fertilizer, we have the CO2 that we will then capture. We need to purify because there are some impurities that can be harmful, especially not for the potential corrosion of the CO2 pipes, and also to guarantee the purity of the CO2 that we will inject under the seabed, and that needs to be also quite pure. And after the purification, there will be a compression and dehydration station. We need to compress at about 165 bars, the CO2, before being capable to send it, and with the CO2 pipe and to the booster station, and then to inject it under the seabed. That's and the purification, the compression here, you can see that we'll need an additional more or less 20 megawatt of electricity. So we will need to connect to a grid to be capable to power this new compression system in our plant. So why CCS? Because we believe Yara, we believe in CCS. We believe CCS is something very efficient, is existing, has been technologically proven, and is really efficient. We have been last year in Australia together with a delegation of Murujuga Aboriginal. We have been in Norway together with a delegation of Murujuga Aboriginal Corporation to show how Northern Lights CCS is operating. And this is similar to what we intend to do. And we have a plant in Holland that's called Sluiskil that at this moment we speak, they are commissioning their CCS facility, and then they will be shipping in the coming weeks the first CO2 vessel into this facility you see on this picture. That's in Bergen in Norway, where they will inject then CO2 under the seabed of the Northern Sea. And this plant in Sluiskil in Holland, they will sequester capture about 800,000 tons of CO2 from this month or next month, hopefully, and this will be already operational. This on the Northern Lights CCS, there is already one plant in Norway, that's Heidelberg Cement, who is already capturing CO2 and shipping it to this plant in Bergen to sequester about 400 or 500,000 tons of CO2 since last year. And one key point is that the Norwegian government has been very helpful to develop the CCS industry because they have funded the first phase of this Northern Lights project by 80%, not only at the Heidelberg cement factory, but also 80% of the new CO2 vessels that will transport the CO2 to this Bergen facility that you see on the picture. And then also in Australia, we have a very good example of CCS works very efficiently with the Moomba CCS facility that has been now is the second year in operation and has already stored 1.7 million tons of CO2 equivalent. And that's more than 10% of South Australia's total emissions. So this is something Santos has started, and almost day one they have started. They managed to reach the operational capacity of sequestration. So it's a very successful story. And so they're also working on a potential development of this project to import CO2 and to continue sequestration in South Australia. And then comes the phase 3 of our CCS decarbonization journey, because I mentioned the URI project, that's phase 1, but 1% of renewable hydrogen. So there is another 14% additional that we could produce as renewable hydrogen to feed our existing plant. And the idea will be this project FREYR will be to install another 120 megawatts, so 12 times more than the URI project within our existing lease boundary. And so we are partnering in this project with electric hydrogen, and so to displace this fossil fuel methane as a feedstock. The key issue there will be the massive need for renewable electricity. So far there is no connection. We are not connected to any grid, and there is no availability of renewable electricity, and we would need about 200 megawatt of renewable electricity to feed this 120 megawatt electrolyzer. So the key issue there will be the feasibility is there. That's not a problem to build a 120 megawatt electrolyzer, but how to connect 200 megawatt of renewable electricity to our plant, and with an affordable price of renewable electricity. So that's still a very early phase of development here. But why this decarbonization journey is so important for us? Because we believe a lot in the future of low carbon or clean ammonia in the future. First for fertilizer, because of course then you don't have any more further emissions, and you can on the applications on the field, because if you convert the ammonia into ammonium nitrate, there is no further carbon emissions, and that's why it is very important to have the lowest carbon as possible when it comes to fertilizer. But then will come something new, and hopefully starting from 2030-31, with the International Maritime Organization obligating the low carbon fuels to be used. Ammonia will be one of the best low carbon fuel to be used for the shipping industry. And we have seen also that the Pilbara can be a perfect location for ammonia bunkering. Just to give you an overview, the iron ore vessels leaving the Pilbara, they have to stop in Singapore to refuel in Singapore, and then they only go after that to Japan, Korea, or China. On this additional journey to Singapore, they lose about 48 hours. So if they imagine that there is a source of low carbon ammonia, and they can bunker and refuel their vessels directly in the Pilbara when they are waiting to be loaded with iron ore, they would gain about 48 hours on each journey going back to Japan, Korea, or China. So that's a big potential saving. That's why we believe the Pilbara is really attractive to develop this future industry industry for low carbon fuels, low carbon ammonia. But then there is another big and important one is co-firing in power plants. And the idea is especially looking at Japan as a key country, pioneering country in co-firing. For example, in Hekinan, JERA is already using about potentially up to 20% and future 30% of ammonia in their power plants to replace coal. So that's also another decarbonization potential. First, decarbonization here in the Pilbara, removing the CO2 from our ammonia. And second, also, if it's used in Japan to replace coal, that's also a decarbonization of Japan. And then also potentially low carbon ammonia can be used to produce technical ammonium nitrate, low carbon technical ammonium nitrate. That's also a scope 3 for the mining industry. That also could help the decarbonization of the Western Australia's mining industry. And then some potential when it comes to CO2, use of CO2, instead of just capturing and sequestrating, we could also use it to develop a sustainable aviation fuel. So the potential future is quite exciting for low carbon ammonia. And it's a bit complex, maybe small on your laptops, but it's what we want to develop, especially working with Japan, because we really believe that we can develop a kind of virtuous decarbonization cycle with Japan that could unlock other partnership and strengthen our commercial partnership between Western Australia, Australia, and Japan. So the key numbers here again, 850,000 tons of ammonia that we produce, 1.6 million tons of CO2 that we emit, but 1.2 million tons can be captured and stored permanently in one of the permanent storage in the Pilbara, could be Angel or Reindeer or else. And there we working with Japanese partners like, for example, Mitsubishi on the technology side, on the compression. We could make this really efficient. And then working with Japan. With Japan, we could then ship more or less 400,000 tons of decarbonized low carbon ammonia. And they can use this low carbon ammonia in their power plant, replacing coal in their power generation. So that will be lowering CO2 emissions of Japan. And at the same time, Japan is also heavily working on possibly capturing CO2 on their other type of plants. So it could be cement factories, could be whatever emissions with potentially flue gas treatment and capture of CO2. And this CO2 they can capture, they could return it back because unfortunately Japan, with their geology, they do not have lots of potential to sequester CO2, but a field like Angel could store up to 5 million tons of CO2 per year. So that means with 1 million ton and potentially up to 3-4 million other tons coming from Japan, that could be a very interesting business model to be developed. And of course, another 300,000 tons that will be used either as low carbon ammonia shipping fuel in the future, or could help also our partners in Australia, in Western Australia, in Queensland or New South Wales to lower their carbon and also to lower potentially other ammonium nitrate, technical ammonium nitrate operations in Australia. And of course, the end is 160,000 tons that we use for our own Yara Pilbara nitrate plant to produce low carbon technical ammonium nitrate. So just to summarize quickly, we consider us as a critical manufacturer. Again, we are the largest ammonia producer. We represent a $2 billion investment total. Our products are critical to supply chain resilience and the sovereign capacity of Australia and Western Australia. Unfortunately, we have seen this this year with the lockout of the Strait of Hormuz, where Australia had reduced the imports of urea, of fertilizer, of fuel. For example, urea imported in Australia, 40% of the urea is coming from plants located above the Strait of Hormuz. That reinforce the idea that we have to be more resilient and more sovereign in our production capacities. And at the same time, unfortunately, Yara Pilbara fertilizer, we have suffered a major outage, unplanned outage. So was also lacking ammonia to produce technical ammonium nitrate. So was also very difficult. Fortunately, we restarted at the right moment because we could also have generated a shortage of explosive for the mining industry in Western Australia. So that's a very important lesson, and that's why our type of operation is so critical for first for Yara, but second also for lots of other operators. So that's why we need to reinforce the long-term viability of the Pilbara as a key manufacturing hub. And what we want to do, that's not only enabling for us, for Yara, this low carbon, low emission fertilizer industrial application, but this will develop a lot of new other potential industries. And of course, we want also to sustain the local jobs and attraction of new capital investment to the Pilbara, because we really believe it's a region, first to be, and second, that is really worth to invest and to develop. Yeah, more or less in a nutshell, that was I wanted to share today.
Thank you, Laurent, for taking the time and sharing that. I think, yeah, it's often easy to take for granted the presence of these large companies like Yara and Yara Pilbara. But I do recall, yes, that outage, and some of our colleagues that were talking about, the day that you opened was almost bang on, that if it had been a day later in the iron ore, things would have got rather calamitous. So I think, the supply chain that happens just in the background for some of this, those connections aren't always made. So thank you for sharing that. And I do recall the Norwegian ambassador, who obviously, Norway is totally different in the way that they're moving towards this, and the government, and for different reasons as well. But talking about, could Australia be the Southern Lights or the Northern, and I remember someone in Poland talking about Eastern Lights. So it's interesting as a global conversation around, mitigation, how we do this. I think it's someone who's been working this for many years, it's not happening fast enough. So we're needing to look at all these different options. But I just thought I'd start off, and then we'll go. There's been some questions in there, but if you could make one change to Australia's policy, and this is hard for you being in industry, not wanting to say the wrong thing, or regulatory environment to help, to maximise decarb in these hard to abate industries, because it's not just Yara Pilbara, what would the change be at this point in time, Laurent? Is there anything you can share?
Yes, there's something that I can share here is that for example, when we develop the URI project, or when we start to develop the FREYR project, we see that there is lots of support when it comes to green hydrogen, green energy. And you have the hydrogen head start, you have ARENA, you have lots of potential support from government to develop such type of projects. But for example, we got 47 million Australian dollar to develop the URI project from ARENA, and close to 4 million Australian dollar from the Western Australian government. But that's more or less to produce, again, it's a 1.9 thousand ton of green ammonia, and we will remove about 6,000-7,000 tons of CO2. So the cost per ton of CO2 removal is extremely high, and when it comes to all the recently announced project supported by Hydrogen Head Start, that's that's fantastic because it's potentially developing new industry. But at the same time, unfortunately, nothing is existing for CCS. We have no way to get funding support because those supports are existing only for one technology, and what we request is that we should be technology agnostic and to have the same type of support for every decarbonization opportunity we can have, and that is technically viable. And as mentioned already, CCS is technically viable and should be as important than, for example, implementing renewable electricity and renewable hydrogen. Because just as an example, if I would get the same support that Hydrogen Head Start for my CCS project, possibly we will go for FID tomorrow. At this moment, there is no support, and unfortunately, the project is not economically viable.
Mm-hmm. Yeah, it's interesting, and there's some questions to that point around CCS, which we'll get to, but I'm just going to start from the top. So Chris McMahon asks, can you give an indication of the cost differential between 1 kilogram of clean ammonia versus 1 kilogram of grey ammonia? And similarly, can you describe the potential premium of clean ammonia and the size of the market?
Oh, that's not an easy question to
Right.
answer. It really depends on where you are in the world and what type of support you get from the governments, or even what type of willingness to pay for a premium you have from your customers. So today we have now producers in China or India, they will guarantee you an ammonia at $600 to $700 US per ton. The market with the unfortunate issue of the crisis of the Strait of Hormuz is now at $600 or $700 US dollar per ton. So the gray ammonia is at the same price than green ammonia. But this is not beginning of the year. The price of ammonia was 300 and something. So it's very volatile and can change very quickly and rapidly. In the long term, we estimate that the price of gray ammonia might be in the range of $550 to $600. But there are already some producers who can produce green ammonia at this level. But of course, they might have some subsidies funding from the Chinese government or Indian government. They have access to very cheap renewable electricity and cheap source of water to produce the hydrogen. When it comes to the project FREYR that we are developing, with the first indication of renewable electricity, we will be far from this price. So then this project will not be attractive unless we have the strong government support. But that then comes again, what's the best the decarbonization per ton of CO2 projects. That's why we prefer to develop a project like CCS. It will not be blue, it will not be gray, it will not be green, but it will be 75% decarbonized. And at the end, what's important is the percentage, the carbon level in the molecule equivalent, so that you are producing and selling. So if it can be but again here the price without support from government will be far above the market. So we will not be capable to sell our ammonia and be profitable if we invest without the support that we are requiring. So then comes for example, in the US, producing blue ammonia or decarbonized ammonia with CCS, with the Inflation Reduction Act that is implemented in the US, is almost the same price or even potentially even cheaper than producing gray ammonia in the US. So it's so generous. It's about $160 per ton of CO2 support that's existing. So if you compare with the safeguard mechanism in Australia, where the CO2 price that we could sell on the market, or if we generate some safeguard mechanism credits, we are at 35, 36 Australian dollar per ton. So we are not playing in the same on the same field. So I'm sorry, I cannot give a very straight answer to this question, but it's so different. And also now the ammonia price is very different. In the region you are, in Europe, the ammonia price is much more expensive because it's more difficult to get ammonia in Europe. So it's also based on the demand. And when it comes to premiums on low carbon ammonia, I mentioned a lot fertilizer. Unfortunately, a farmer in Africa and Asia will not be capable to pay a premium for his fertilizer. He's already representing 30-40% of his total cost, the price of fertilizer, and adding some additional premium. Unfortunately, with the margin a farmer has, they will not be capable to add some premiums. So unless support and subvention from the different governments, this will also very difficult to get premiums on low carbon products.
Yeah, it's actually quite well, I found it very insightful to see the range of the costs of ammonia per ton in the world globally. And when you're trying to compete on this, it varies a lot, right? And there's so many different things to make it competitive. I'm just going to go through. Leo posted this quite early, but I think you've actually answered it. But he was just asking around the producing 0.9% of ammonia we need. I think this was to do with the renewable energy project Yuri. Could you just clarify that 0.9%? I think
Yeah.
this was to do with the
So
emissions.
the Yuri project, the 10 megawatt electrolyzer, will produce, I don't have the right numbers exactly, 600 or 700 tons of hydrogen per year. And that's basically the need is 0.9% of our total hydrogen need to produce this 850,000 tons of ammonia. So that will produce this 0.9% will produce 1.9 thousand ton of clean ammonia of our total 850,000 tons.
So it's minuscule.
Yeah, that's why we call it a pilot, almost a pilot demonstration, but it's by far the biggest electrolyzer in Australia. The biggest in operation today is 1 megawatt, and we will go for 10 megawatt, and we call it a pilot.
Yeah, we've got a long way to go to scale hydrogen. But I know these aspirations that you've got. Warren Morey's asked a couple of questions, which I'll try and wrap in a little bit. One was around to do with Orica Hunter Valley ammonia reaching FID on hydrogen hub. It's apparently going to supply 7.5% of its energy needs. And then asking why can't Yara increase its hydrogen production, which I think you've talked about, but also the aspirations for Freya. And then surely CCS is more expensive, which you've sort of talked about, but also pointing to the underperformance of Gorgon. I don't know, that sort of wraps in a couple of questions, but I'm sure it's probably easier to answer those.
Yeah. So first with the Orica Hunter Valley, that's 7%. Yeah. This project will get a total of more than 500 million Australian dollar support over the lifetime of their project. This is to produce, if I remember the numbers, is to produce about 500 or to decarbonize about 50,000 tons of CO2 per year. So So that's what's again what's the most important? Is it to produce a green ammonia, or is it the quantity of CO2 that we remove from the atmosphere? So we are the key urgency is really removing CO2 from the atmosphere. So if I would get $500 million, the equivalent, I would again get the FID directly approved from Yara, and that I would be capable to remove 1.2 million tons per year of CO2. So that means with the same amount of support, with my project could remove 25 times more CO2 per year with the same funding support.
And let's face it, CO2 is the challenge here.
Yeah.
We're all greenhouse gas more broadly.
And the second part, surely CCS is more expensive than hydrogen. CCS is by far much cheaper than renewable hydrogen. So that's when it comes to capex, when it comes to maybe not really the opex, because we need also some compression, transport, and sequestration costs. But overall, the easiest and more efficient solution when it comes to capex per ton of decarbonization is CCS compared to green hydrogen.
Tim Bateman asks around your proposed timeline for Project Freya.
Just also mentioning a Gorgon project. Yes, some results are showing underperformance, and this is clear, and that's why it's still an emerging industry that's still on the learning phase. So lots of learnings came from Gorgon. If Gorgon would have to be redesigned today, it would have been designed in another way and would operate according to denominate the nameplate capacities. Unfortunately, what is installed cannot perform more, so that's but it's a key learning for the future projects. And what we have seen in CC in Northern Lights in Mumba is that it's also depending on the geology of where you sequester your CO2. So the geology of the depleted gas fields we are looking at in the Pilbara are much different that Gorgon, which is an aquifer. We are really working on depleted gas field, which is much different, and this geology is much better known in order to design it properly.
Okay, I'm going to keep moving. There's lots of questions coming up, so we won't take them all in order. But
yeah, the project Freya, the timeline is really depending on the electrification of the group and the massive availability of 200 megawatts of affordable renewable electricity. But we expect that both CCS and Freya could be operational by 2031, 2032.
You also need a transmission line, right? Is that right?
Yes, a big one. Yes.
We need transmission lines all across WA. Ramadi Triastomo said, are there any plans to collaborate with the Australian iron and steelmaking industry or a university to use ammonia as a carbon-free method for reducing iron ore to iron?
There are some interesting projects like POSCO in Port Hedland. They are potentially also evaluating and looking at using low carbon ammonia to produce low carbon steel. So yes, there are some potential. We are not directly working with the steel making industry, but we are discussing together.
And you are decarbonising the production side as you decarbonise your town, right?
Yeah, that's the scope 3. Yeah, that's a bit the difficult part because again, when it comes to premium, scope 3 is not regulated, is not followed, so no one cares so far. But it's a real emission, so that's something also that could help also to now we will start to monitor more closely what is scope 3 in Australia, and hopefully there will be also interesting project coming out of this.
Thank you. Brian Haggerty says, are there regulatory changes needed to implement your low carbon vision?
Regulatory changes, maybe not. We are now exciting to see what will be the revision of the safeguard mechanism. We believe in the safeguard mechanism. That's something that can help, but there are some changes to be done, some improvements to be done to make projects like ours viable. Yes.
Okay. And then Lisa, I'll read this out. Laurent, thanks for your presentation. I'm wondering if you can give some insights into how WA stakeholders, brackets, iron ore proponents, Pilbara Ports, WA Gov, iron ore cargo, and of course Yara, as potential green ammonia supply can work together to accelerate investment and delivery of Australia East Asia iron ore green shipping corridor.
We are working closely with Pilbara Port authorities, Western Australian government, because Roger Cook is a strong supporter of this low carbon ammonia as a shipping fuel, and so of course then we are discussing also with the iron ore producers. Of course, Fortescue is one of the key leader in this, and BHP, Rio Tinto. We have signed MOUs with Rio Tinto already, with working with them on developing the workforce of the future, and when it comes to low carbon fuels. So we have made the first ship to ship ammonia transfer that simulates a bunkering operation. This has been at the Anchorage Point, has been the first time in the world that has been done. It was in Dampier in our port. So we are very collaboratively working. The idea, of course, is to work more to have a working group that's not really existing, that because it's a separate discussion, Yara with the port, then the port with Fortescue, the port with the. But if we could have a combined working group with all the key stakeholders, could accelerate things.
Collaboration is the key when it comes to
Agree.
decarbonisation. There's several things that sort of come to the same point, but I'm going to go to Richard Bentley's question. The expected, which I think you sort of talked to, the expected cost trend is for renewables to keep falling and for gas and oil to keep rising. Does this not indicate prioritising renewable options is the best path? There's several that sort of talk to this sort of conflict. Yeah.
Yeah, we see that in our operation. I'm now in Australia since close to 6 years, and I have seen the price of gas tripling for my operation. And gas is representing already 80% of my total cost. So yes, those prices might increase, but unfortunately, at the same moment, cost of renewable electricity, for example, and the first indication of cost of price of renewable electricity, transmission of this electricity to the Pilbara, to the place I operate, are prohibitive. So then that's something that we have to see what would be the impact, but at one moment the offer and the demand will be the limit. So if prices of renewable will be too high, if prices of oil and gas will be too high, the demand will be lowering and will stabilize again in a place where people can afford it.
Okay. Some of these questions, and you might understand them better than I. So Mark Lou asks, what operating strategy would Yara consider most practical if the renewable hydrogen supply suddenly drops or stops, which I haven't got it there anyway, hydrogen buffer storage, increasing hydrogen production from natural gas, or reducing ammonia production? What is the main constraint behind those choices?
So the renewable hydrogen supply, the problem with hydrogen directly is the supply chain, and it's a very complex supply chain. Storage of hydrogen, transport of hydrogen is not easy. That's why in Yara we prefer to convert this hydrogen into ammonia, because all the supply chain of ammonia is already existing, and it's better to it's safer to ship and transport, and cheaper to transport ammonia, refrigerated ammonia at minus 33 degrees, for example. That's at atmospheric condition, so very easy to transport and to store safely. in a plant like ours, we won't have storage of hydrogen. All the hydrogen that will be produced by electrolyzer will be feeding directly the production process. So if there would be a shortage of renewable hydrogen, then the impact will be the immediately reduction of ammonia production.
Yeah, yeah. Okay. Um, what's this, Leo? He talks about 20, which I think you've talked about, 20,000 PV panels to produce less than 1% of ammonia. Makes me think, actually, he's being naughty here, that producing hydrogen with solar energy is not sustainable. Is Yara looking at nuclear power plants outside Australia, though, dedicated to low carbon hydrogen to scale up? So I suppose France, maybe.
So I'm French by origin, so I can say why not in Australia, but Uh, let's say just we are developing there's this small nuclear reactors that could be up to 10 megawatt 10 10 gigawatt of production. Uh, that one of the small reactor could feed five ammonia plants like mine. So it would be low carbon ammonia. In Europe, for example, we have an ammonia plant in Le Havre in France. It's already fed with almost very low carbon electricity. So that's something that we could develop because if you look at France, for example, 95% of the electricity produced is low carbon. 75 is coming from nuclear, and another 35 is from hydropower or wind and solar. So yes, I do believe a mix of the right and low carbon electricity is the best development for low carbon ammonia also.
Mhm. I'm going to Dora's. We're nearly out of time, but can you comment on any risks associated with CCS under the seabed and how they're addressed?
But the key risk potentially with CCS is the sequestration, is that uh, the field is not tight and there are some CO2 emissions to the ocean. So so that's why the geology is the most critical, and so that's not Yara's expertise, but we trust a lot on the one really expert in this. So we have also to be far from places where with risk of seismic movements that can break and do some cracks. So the geology is the key part of it, and to guarantee that, and of course the monitoring of the fields will be extremely important to guarantee that everything is tight and does not move.
In my understanding, that's what Sleipner's done for many years, and the Northern Lights similarly will do the same in the MMV. It's very transparent. I mean, yeah, I didn't quite get to Northern Lights, but because of a workers' strike. But the idea is that it's very much almost like a tourist spot, right? People can go in and see and watch that almost, yes, in the monitoring. It's very transparent in what they're trying.
Transparent, yes.
Yeah. But thank you for that. There's just, I probably might stop there, but for questions around students and so forth coming to visit or what have you, I would suggest that you contact the Institute and we can filter that through, because Yara is very strong on knowledge sharing in all of the things that they do. And I know we've partnered through the West Australian School of Mines. There's some opportunities there for students coming on campus to see it. I mean, there's also the challenges of how you operate within that island space. There's a lot of things that I think are great to learn practical. So for Salongo, if you want to email us, we can certainly do that. But look, Laurent, thank you so much for taking the time. I think to me, what I've learned, working with Yara also is interesting. May I share all of the interviews that we did with people, how much your workers love being a part of the Yara culture. And even when I went to visit in the head office, there was actually loud Brazilian music because it was Brazil Day. So that's also quite rare within companies. So I think there must be something that Yara Corporate does in making this a place to work, but also the aspirations to be responsible in the decarbonisation journey.
Yeah, I just can confirm that Yara is a great place to work. My 28th year in the company, and you mentioned Brazil. I've lived 5 years in Brazil, 4 years in Colombia. So with the Latin culture also that I want to be to transmit and bring to the Pilbara at the same time.
Yeah, no. But it's also interesting. So on our website, there is the case study if people are interested to look in more detail around the economics and those sorts of things. And any questions, we're happy. Please just send them to the Institute. Laurent, it's been really great to have this time and you
Thank
take
you,
time
Peter.
out of your busy day. Just to give a bit of a plug that next Thursday the 20th is it next week or the week? I've lost track of the dates. All hands on deck, lowering shipping emissions with DMV. So another Norwegian company. It's interesting that a lot of these activities are being led by Norwegian companies, but there'll be a nice link, I'm sure, with ammonia and the opportunities. So thanks again, and thanks everyone for participating and for all your questions. It's great.
Thank you very much.
Take care.
Have a great day. Bye bye.
Bye.